Question 12. Figure 3 is a graph of the trajectory of a golf ball after the ball has been hit until it first hits the ground. The vertical height h meters of the ball above the ground has been plotted against the horizontal distance travelled x meters, measured from where the ball was hit. The ball is modelled as a particle travelling in a vertical plane above horizontal ground. Given that the ball is hit from a point on the top of a platform of vertical height 3 meters above the ground, reaches its maximum vertical height after travelling a horizontal distance of 90 meters, and is at a vertical height of 27 meters above the ground after travelling a horizontal distance of 120. Given also that h is modelled as a quadratic function in x, part A, find h in terms of x. We're told that h is modelled as a quadratic. I can see quite clearly from figure 3 that this will be a negative quadratic, but for now, let's write out h as a quadratic function. So h is equal to some ax squared plus bx plus c. This is the equation of a quadratic function. Looking at this first point here, it says it is hit from a point on top of a platform of a vertical height 3 meters above the ground. This means when x is equal to 0, h is equal to 3. This coordinate can be seen on figure 3. Substituting these values into our currently unknown quadratic function, 3 is equal to 0 plus 0 plus c. Therefore c must be 3. And so we can rewrite our quadratic equation now as h is equal to ax squared plus bx plus 3. But we still have two unknown values, a and b. So let's look at our next two bullet points. It reaches a maximum vertical height after travelling a horizontal distance of 90. What do we know about the turning point of a quadratic function? We know that the gradient at that point is equal to 0. And so we know when x is equal to 90, dh by dx is equal to 0. So let's differentiate h. So differentiating h with respect to x, multiply by the power, subtract 1 from the power, 2ax, bx differentiates to b, and 3 as a constant differentiates to 0. So we have the derivative function is equal to 2ax plus b. When x is 90, this should equal 0. Therefore 0 is equal to 180a plus b. This is a nice equation to have, but still two unknowns. So let's look at point 3. It is at a vertical height of 27 meters after travelling a horizontal distance of 120. Well, this gives us the condition that h is 27 when x is 120. So we can put these also into our equation for h. So 27 is equal to 120 squared, 14,400a, plus xb, so 120b plus 3. Now again, this equation has two unknowns, but if we bring in our first equation, rearranging this, we can see that b would be equal to minus 180a. I can substitute that into this equation, so taking 3 from this 27 to give me 24, is 14,400a plus 120 of b, which is minus 180a. Expanding this bracket and simplifying gives us that 24 is equal to minus 7,200a, which gives us a value of a of minus 1 over 300. Now we can multiply this by negative 180 to find that b is equal to 3/5. And now we have a and b. We have our full quadratic for h. H is equal to minus 1 over 300x squared plus 3/5 x plus 3. Part B. Hence find, according to the model, part I, the maximum vertical height of the ball above the ground. Well, we are told that the maximum height is reached after a distance of 90. So the maximum h is found when x is 90. We can substitute 90 into our equation for h, and we get an answer of 30 meters. Part II, the horizontal distance travelled by the ball from when it was hit to when it first hits the ground, giving your answer to the nearest meter. Well, at the point it hits the ground, we can see that h is equal to 0. So when h is equal to 0, in our equation for h, 0 is equal to the following quadratic. At this point, let's jump to our calculator. So if we go to menu, scroll down, we want a here to solve an equation and a function. We're solving a polynomial of degree 2. So my first value is negative 1 over 300. My x coefficient is 3/5, and my c is 3. This gives me a value of 184.86 and so on, and negative 4.868 and so on. And we've seen x can either be 184.86 and so on, or minus 4.86 and so on. Of course, it cannot be negative. So the value of x we want is 185 to the nearest meter. Part C, the possible effects of wind or air resistance are two limitations of the model. Give one other limitation of this model. Now my advice with limitations is to read through until we find something that is a modelling limitation. So we've got the trajectory of a golf ball after it was hit. The vertical height of the ball has been plotted against horizontal distance from where it was hit. The ball is modelled as a particle. This is the first point where modelling has been mentioned, and we've got the ball is modelled as a particle. This is an extra limitation to this model.